Lesson: Fundamentals of Predictive Analytics in Supply Chain Management. Predictive analytics in supply chain management represents a revolutionary approach that leverages historical data and statistical algorithms to forecast future outcomes and trends. This facet of analytics offers supply chain professionals actionable insights that can enhance decision-making processes, minimize risks, and optimize operational efficiency. As businesses strive for competitive advantage, integrating predictive analytics into supply chain management is becoming essential. This lesson will explore the core components of predictive analytics, practical tools, frameworks, and step-by-step applications that can be implemented directly to address real-world challenges. Predictive analytics is grounded in the ability to predict future events based on historical data. By applying various statistical models and machine learning algorithms, businesses can identify patterns and trends that inform strategic decisions. For instance, a company can predict demand for a product by analyzing past sales data, seasonality, and external factors such as economic indicators. This enables companies to align production schedules, manage inventory levels, and optimize logistics, ultimately reducing costs and improving service levels. One of the key tools in predictive analytics is regression analysis, which models the relationship between dependent and independent variables. In supply chain management, regression can be used to predict demand by examining factors such as pricing, promotional activities, and economic conditions. For example, a retail company may utilize multiple regression analysis to understand how different marketing strategies impact sales volume. By doing so, they can allocate their marketing budget more effectively, targeting strategies that yield the highest returns. Another vital component of predictive analytics is time series analysis, which focuses on analyzing data points collected or recorded at specific time intervals. Time series analysis is particularly useful in demand forecasting, as it can account for trends, seasonal patterns, and cyclic behaviors. For instance, a manufacturer might use time series analysis to anticipate fluctuations in raw material demand, allowing them to adjust procurement strategies accordingly. This can lead to significant cost savings by avoiding overstocking or stockouts, which can disrupt production. Machine learning algorithms, such as decision trees, neural networks, and support vector machines, have also become integral to predictive analytics in supply chains. These algorithms can handle large volumes of data and complex relationships, making them ideal for predicting supply chain disruptions or identifying fraud. For example, a logistics company might implement a machine learning model to predict delivery delays based on real-time traffic data, weather conditions, and historical delivery performance. By proactively identifying potential issues, the company can take corrective actions to mitigate disruptions and maintain customer satisfaction. Frameworks such as the CRISP-DM provide structured methodologies for implementing predictive analytics projects. The CRISP-DM framework consists of 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. By following this framework, supply chain professionals can systematically approach analytics projects, ensuring that all relevant factors are considered and that models are rigorously tested before deployment. This comprehensive approach minimizes the risk of errors and maximizes the potential for actionable insights. A practical case study that illustrates the effectiveness of predictive analytics in supply chain management is the implementation by a leading global beverage company. By leveraging predictive analytics, the company was able to forecast demand with greater accuracy, resulting in a 20% reduction in inventory levels and a 15% improvement in order fulfillment rates. The company achieved these results by integrating data from various sources, including point-of-sale systems, social media, and weather forecasts, into their predictive models. This holistic approach enabled them to anticipate demand spikes and adjust production schedules proactively, thereby optimizing their supply chain operations. In addition to enhancing operational efficiencies, predictive analytics can also play a crucial role in risk management. Supply chains are inherently vulnerable to disruptions caused by factors such as natural disasters, geopolitical events, or supplier failures. predictive analytics can help organizations assess the likelihood and potential impact of such events, allowing them to develop contingency plans and build resilience. For example, a company might use predictive models to identify suppliers at risk of financial distress and diversify their supplier base to mitigate potential disruptions. The application of predictive analytics in supply chain management is not without challenges. Data quality and availability are critical factors that can impact the accuracy of predictive models. Companies must ensure that they have access to reliable and relevant data, which may require investments in data infrastructure and governance. Additionally, supply chain professionals must possess the necessary analytical skills to interpret model outputs and translate them into actionable strategies. This highlights the importance of continuous learning and upskilling in the field of predictive analytics. In conclusion, the fundamentals of predictive analytics in supply chain management provide a powerful toolkit for enhancing operational efficiency, optimizing resources, and managing risks. By leveraging techniques such as regression analysis, time series analysis, and machine learning, organizations can gain valuable insights into future trends and make informed decisions that drive business success. Frameworks like CRISP-DM offer structured approaches to implementing predictive analytics projects, ensuring that all critical factors are considered. As demonstrated by real-world case studies, businesses that effectively harness predictive analytics can achieve significant improvements in inventory management, order fulfillment, and overall supply chain performance. However, to fully realize the benefits of predictive analytics, companies must address challenges related to data quality, availability, and analytical capabilities. As the field of predictive analytics continues to evolve, supply chain professionals must remain agile and adaptable, continuously seeking to enhance their skills and knowledge to stay ahead in an increasingly competitive landscape.